So today we're just going to, at the top, we're just going to finish up with a couple of miscellaneous things regarding sorting, and then we'll move on to some practice problems here. Stability in sorting means, well, here's the definition. An algorithm is stable if it always keeps relatively equal things in the original order. And what I mean by that is, here's an example, right? Suppose that we have the following four numbers here. 10, 3, 4, and 3. Now, the A and the B there, I've just used those as labels. They don't pertain to the actual numbers, right? So if you were to sort this, it would end up being 3, 3, 4, 10. But now there are two distinct 3s in there, right? A stable sorting algorithm would never put them out of order. It would have, the original order of 3A and 3B, that would be preserved throughout the entire process. But an unstable sorting algorithm could result in something that looks like this. 3B, 3A, 10, 4, and 10, right? It's still sorted, but those original 3s, their original positions have been transposed, right? Generally, you can take any unstable sorting algorithm and you can make it to be stable by doing some extra work, right? Alternatively, you could always come up with some sort of unique tiebreaker so that those 3s are distinct. I did that by slapping on an A and a B, right? The way that we covered quicksort is it's unstable. Why? Because you're throwing elements over here, you're throwing elements over there, and you're not making any consideration for the original ordering, right? So, for example, if you chose a pivot element of 5 and you suddenly saw another 5, well, that would go over here because it's less than 5. Suppose that it was afterwards, and so it gets swapped over here, right? And so now your pivot element, when you place that, it's going to be after, whereas before it was before, right? So quicksort as we presented it was unstable. Selection sort as we presented it was stable. Why? Because we used a strictly less than instead of less than or equal to, right? If you'd used a less than or equal to and, okay, here's the minimum, well, here's something that's equal to the minimum, we'll go ahead and put that in the front, right? Then you would have ended up swapping them because now I've transposed my hands here. But if you're always using strictly less than, then you're always favoring that first minimum value, right? So that's stable, right? And why would you want something like this? Well, I've got a demonstration over here. Let me go ahead and do a hard reset here. Yeah. All right, so let's go ahead and sort it by last name, first name. There we go. So I've got first name, last name, et cetera, right? It's Baez, Castro, Jackson, et cetera, right? Now, if I hit that same sort button over again, would you expect it to make any changes? Right. It's already sorted in that same order, right? But now the built-in sorting algorithm that I'm using here is for JavaScript. The built-in sorting algorithm is clearly unstable because anytime you resort it, now nothing changes over here in the last name, first name column, but you see the records transposing in and out of each other, right? You don't want that generally. Why? Well, what if you wanted to sort by one column and then by the other column? For example, I wanted to sort by year here. Right? I want all the freshmen, all the sophomores together, but then I want to also sort by their first name, last name because I want to create a roster. Right? If I first sort it by first name, last name, and then I sort it by year to collect all of the same year people together, there's no guarantee that the original order, alphabetic order for last name, is preserved. Right? So if you're ever trying to do more than one column or more than one piece of data, you probably want some sort of a stable sorting algorithm. Right? The second item is going to be natural versus artificial orderings. Right? So consider that same set of data. Right? If you wanted to sort students by year, right? Then freshman, sophomore, junior, senior, that would be the artificial ordering. That would be the ordering that you would want, right? Because freshmen, you know, the order is freshman, sophomore, junior, and senior, right? So junior to, or the newest students to the most experienced students. But if you were to sort those as strings, what would end up coming first? Freshman, yeah, great. But then what comes up second? See, who? Yeah, junior because of J, right? Then what comes next? Senior, and then finally sophomores are last, right? That would be the natural ordering, right? That would be the natural ordering because there's a lexicographic ordering on the strings, right? So I don't want that to happen. I want it to look much better. If I sort by year, I want it to look like this: freshmen, sophomore, juniors, and seniors. So do you think that I was sorting by the names here? Now, what's the solution in C, say? What could I use besides strings to represent the year of a student? Well, there are only 4 of them, right? And if I want a particular order, I would want to list them out. In C, we call lists what? Enumerations, right? So if I created a freshman, sophomore, junior, and senior, right? Now, internally, what happens here? Freshman gets a value of 0. Sophomore gets a value of 1, 2, and 3. Now it's naturally ordered, right? Now, of course, if I ever want to convert freshman into the string freshman, now I need yet another function to do this for me, right? I would have to write that function. Or if I wanted to convert from the string into the enumerated type over here, right, then I would have to do that as well, right? But otherwise, now my sorting problem is, the artificial sorting problem is now solved, right? Okay. So we've covered a lot with respect to searching and sorting. Linear search, it's linear because it makes about n comparisons, right? Binary search, that requires it to be sorted, but it makes log n comparisons. And then we sort of covered 2 sorting algorithms, selection sort and quick sort. Selection sort was slow. How many comparisons did it require? Do you remember? Oop, no, not there. Find selection. There we go, selection sort, right? So how many comparisons? About n squared, right? Now quick sort was much quicker, right? On average, or in expectation, it's going to be n log n. We call that quasi-linear, right? So there, and of course then what do you do in practice? As you saw yesterday in your lab, you don't roll your own, you use whatever's built in. For C, that's going to be quick sort. For Java, that's going to be collections.sort. Okay? Then you create comparator functions in C or comparators in Java. All right, any questions on searching or sorting? All right. Yes, well, I will bring old exams next week. But what I wanted to do today is I wanted to go ahead and do Advent of Code. And I haven't done it yet, so you can see that I don't have any stars yet, but I did read through the prompts, not for 3. We're gonna do day 2 in this class because I'll do day 1 this afternoon in the main section. We're gonna do 2 because it's more difficult, right? And so this is the honors section. So you can read through if you really want to. It's like, I forget what you're trying to do this year, but you're trying to save Christmas basically. That's what you're trying to do every year, right? It doesn't really matter. You've got what you're given as input here, a list of ranges of integers. So like 11 through 22, 95 through 115, whatever that number is through whatever that number is, right? And then you're trying to check to see if there are invalid IDs, right? Now invalid IDs are, first of all, they're IDs that are double numbers, so 11, 22, 33, or 99, or 1010, right? Or 1111, so 1111, right? So those are the ones that we need to consider, okay? And this is also wait, has only one invalid ID. Oh, okay, no, that and then that is repeated. That's it, right? Right, there. I was just misinterpreting it for a second. And then 446, 446. So those are all invalid IDs, and they lie within one of the ranges of the inputs. If they lie outside of the range of the input, it's not invalid, right? So as one invalid. So what you're doing is you're trying to find all of the invalid IDs that are within one or more. Actually, there's not more. I did check this, that there are no overlapping sequences. There are no overlapping ranges. How far do you keep going? Because of course you can have an infinite number of those doubled up numbers, whatever they call them, right? Well, what you need to do is you need to find the maximum value here, and then you don't need to go beyond that, because once you've got the maximum value, then anything beyond that is valid, right? So as an example here, 11 and 22 are both invalid because they lie within this first, it's inclusive on both ends, right? That sequence right there. 99 lies between 95 and 115. 1010 lies within that one, et cetera, okay? I don't know, the rest of all the ranges contain no invalid IDs, okay? So for this particular input right here, right there, right, then we have, well, I think it was 8, or no, I guess you're supposed to sum them up, right? And so immediately I can almost tell that we're going to have overflow if we go with conventional integers here, right? Because the actual puzzle input here, let's go ahead and take a look at it. I don't know if it's sorted or not. No, it's definitely not sorted, right? So going to get some practice searching and sorting here. But also, I'm pretty sure that these numbers are too big. Yeah, that's 8 trillion. So you're not going to be able to hold that in an integer there. That's why I'm doing it, this one in the H class right here, okay? So what I like to do when I approach these things is, of course, I'm going to test it because you can submit an answer right away if you want to, but then it throttles you and you have to wait like a minute or 5 minutes if you get it wrong. I think that you have an infinite number of submissions, but whatever. All right, so let's come over here to lecture. Let's just go into 155H. Oh, lecture CSC 155H. And I'll touch the input.test and touch the input.full, maybe, and touch advent 02, because it's day 2, right? .c, right? And let's go ahead and refresh this. So there's the input test. There we go. And by the way, they're supposed to be on one single line. They just wrapped it so that it would look nice. And then here's the actual input. And so I'll go ahead and copy and paste that and put that over here. It is indeed one line, but it's not sorted. Right? So we're going to have to keep that in mind there. All right, so the way that I'm going to do this is, well, I need to start over here, include stdlib.h, include stdio.h, right? And int main, int argc, char, argb, right? All right, so now that I've got the boilerplate up and running here, return 0, right? What's the first thing that I need to do? Let's give myself some more room over here. I need to open up the file and process it, right? I need to process it such that I'm just going to look at the test here because it's smaller, right? So what I'm looking at here are pairs of numbers. So a lower bound and then an upper bound. And I'm going to assume that I did check at least the test input here, that there were no overlap. No, I just tested both. There aren't going to be any overlapping like ranges, right? So you wouldn't have to, that would have been maybe something for day 10 or something like that, where okay, now you have to determine, because you don't want to count anything in there twice, basically. And so you'd have to collapse them all. We don't have to do that here, I'm pretty sure, right? But I do need to capture both of those. So what I'm going to do is I'm going to open it up for processing, right? So how do I open up a file? I need to create a file pointer first, and I'll call fopen, and that's going to be input.test, right? Later on, I'll change that into input.full to get the full. And then I'm going to open it up for reading, the purposes of reading. I'm going to read this. Ooh, this is a good question. Should I read this line by line? There's only one line, right? So let's go ahead and just get that one line, right? Only one line. Right? But if I had multiple lines, what would I do? I'd go into a while loop, and while forgets, while that doesn't return something null, then I will read the next line, right? But otherwise, there's only one line, so let's go ahead and get that one line. Forgets. And what are my arguments to this? I need the buffer, or the line, the single line, or just call it data, whatever you want, right? At most, however big this is, and then reading it in from the file, right? So let me just go ahead and create this big enough so that it holds the full values over here, right? And unfortunately, there's no column counter by default over here, but you can always go to, oh, actually, no, forget this. I don't want to do online. Let's go ahead and do word count of input.full, right? And there are 507 characters in there, okay? Otherwise, what I was going to do is I was going to copy and paste that into an online character counter, and it would have told me there are 507 characters in there. All right, so let's just go ahead and make it big enough, right? I need a string, right? Char data, and I'll just make it what, 1,000? That's good. All right, 1,000. All right. And then I want to process that string by going through it and saying, okay, 1, 1, great. except that now we've got that's not a minus sign, that's a through, right? Whatever you call that thing. And then you've got commas there as well, right? So how can I process that one string? What's the tool that we were using to process a file that had data, delimited data like that? We split it up into tokens, right? And so str toke, right? And I will want to have a while loop to do that because I don't know how many up front that there are going to be, right? So I need to do it the first time, right? Find the first token, right? And so that's str toke. And the first time that I call it, I pass in the string that I want to tokenize, data, as well as the token or tokens in this case that I want to process. Now, if I just did that, well, if I wanted to tokenize this, I would say, all right, well, they're all split by commas here, but then I would be left with this token, so I'd have to re-tokenize that anyway to do the hyphen or whatever that's called, right? So what I'm going to do is I'm going to do it all at once. Remember, you can use multiple tokens in there, right? So that will split on any one of those tokens. I will get this number by number and by number. All I need to do is make sure that the first token is going to be the first number, and then the next token is the second number so that I have this range here, right? So let's just get the first two tokens then. Two tokens. And this will be, I don't know, char A. I'll just call this char A and char B for now, str toke. Now, the second time I call it, what do? Do I pass in data again? Nope. What do I pass in? Nope, null, to make it go with the same one as before, right? And that is the order, I believe, right? Let's go ahead and print it out to make sure. Printf %s. And actually, let's go ahead and convert them immediately because they are integers, right? Or are they? Does that look like an int to you? That's much larger. So what can we do, like you just learned in your lab 12 that we're grading right now? What's bigger than an int? A long, right? So let's go ahead and go with long x and long y for now, right? Obviously, we're going to need to process all the rest of them. But this will be a2, I don't know, of b. And this will be a2, I don't know, of a. Right? So if it was I, then it would convert it to an integer. Is there a L? A2L? Let's find out. Did we get a toll? Okay. C programming. There we go. In fact, there is. A2L, what does it return? A long. In fact, there's a toll, A-T-O-L-L, that will return a long. I believe that you use longs, right? Those are 128-bit numbers, at least on the machines that we were running it on. So it was much larger. I don't think we need to get that large, though. We might. We'll find out here. Again, I've not solved this yet because I don't have my stars yet. So it could be very it could be the case that I'm not going to be able to solve this today, right? I don't know. We'll find out. Right? Now let's make sure that these are actually, I'm reading this incorrectly. Printf x and y are equal to %. I think it's LD. Is it? %LD, long digit, x and y. Let's just make sure that we're reading the first two tokens here. Advent. Oops. All right, so if I'm doing string stuff, what do I need? String library, right? Those are only warnings though. All right, and that's the only warning. All right, so a.out, 11 and 12, well, 11 and 22. So I have some confidence here that I'm reading in the first two, okay? And so I need to now go into a loop to get the rest of them. Before I do that though, how am I going to be storing these? I need some sort of an array, right? But at the same time, I mean, I could have an array where I have the lower one, the higher one, the lower one, the higher one, the lower one, the higher one. And so I could just have a whole array of longs if I wanted to, right? But this is a review. If I want a pair of numbers representing a range, right, what should we do? If I've got two pieces of data that I want to wrap up into one range, right, let's do a typedef struct. Right? Now, if I was just doing something quick and dirty, I wouldn't do this, but it's a review, so that's what I'm going to do. Range. Right? And it's going to be long, lower, right, and long, upper. Right? I like lower and upper because they have the same number of characters, and so it'll align in your code everywhere, right? Or low, low. You can do low, high, but then that doesn't align up, right? You could do LO and HI, but then those are too abbreviated. I don't know what those are. Right? All right, so how many am I going to have here? That's a good question. Because I need to create an array now of ranges, right? I need a range, R ranges is equal to range malloc of size of range, right? Oh, here's a common error that we see all the time, right? Times however many there are. Why is that a bad, I mean, it's range, right? This is why we use conventions like lower camel casing and upper camel casing. Hopefully that's screaming out to you that that is the actual pointer there. Actually, there is no range in scope here, so it wouldn't compile. But if I had called this range instead, then it would treat it as the pointer, which is only 8 bytes. But this is definitely different because it's, let's see, 64 bytes plus 64 bytes. That's 120 bytes, right, for that entire thing, for each one. Right? All right, how many am I going to need? Well, I could go through and count them. 1, 2, 3, 4, right? So you read a file into memory using, in hack 10, right? And the first thing you had to do was you had to go through and count up the number of characters or the number of lines in the second one in order to determine, how big of an array you need. We have to do the same thing here, right? First of all, let's go ahead and count the number of hyphens and commas. Why is that going to tell me how many numbers there are? Say that there are, 9 of those. How many numbers are there? 10, right? Because those are the delimiters, right? So let's go ahead and count. Set it at 0. If I don't set it at 0, that goes back to week 1. What value is there in C? Who knows, right? So 0, always initialize your variables, right? What I can do is I can say for int I equals 0, I is less than something. You're going to tell me that, I++. I'm just going to look at each one of those characters. If data of I is equal to either the hyphen character or data sub I is equal to the comma character, then I will increment printf, or not increment, but count ++. Okay. Now remember, if I'm counting 9, then there are actually 10. So int numbers, right? Numbers is equal to count +1, and that's what I'm going to use right here. Now you tell me. How do I know when I'm at the end of a string? Okay, yeah, well, you could do it like, have I hit the null terminating character yet? Or, I would use a while loop in that case, right? Because I don't know up front how many, but strlen of data. All right, that's what I'm doing. This is the straightforward way. The way that you're suggesting is probably better because you only go over the string once, right? Here I'm going over it twice. Once to count up the number of characters using strlen of data, and then twice, the second time here, to actually iterate over the loop for each character. Now, you might ask yourself also, wow, does that actually get called on every single iteration? And I think that the compiler is smart enough to see that you're not changing the data, so it will only call it once, right? But that's a compiler optimization, right? Okay. All right. Well, I don't know if this is correct or not, so let's go ahead and say printf numbers is equal to %d and the line, and numbers. There we go. All right. And let's just make sure that this works. Oops, what did I do wrong? Comma. Can't believe I did that. All right. A dot out. 22 numbers, is that correct? All right, well, there's 2, 4, go away, 6, 8, 10, and I lost count, 12, 14, 16, 18, yeah, it looks like 22 to me. Yeah, all right, cool. All right, so let's go ahead and get rid of our poor man's debugging here. All right, there we go. Now I can get rid of that debugging too. All right, actually let me restore that because I do want to make sure that I'm reading everything in. Notice here that we've taken the 15 minutes already to read in the input. When I did this, I didn't solve it yet, but I came up with a solution that worked on the test input. I haven't tested it because I haven't got my stars yet on the full input, but I did it in Python and I could do it, read it in like 2 lines. So, and get it in the form that I wanted in 2 lines. All right, so find the first 2 tokens. Now how do I find all the rest of the tokens? What do I do with those tokens now, by the way? Ranges of 0 ends up dot, lower ends up being x, and ranges of 1 dot, or sorry, 0 dot, what is it, higher, upper is equal to y. Right? I'm going to store that. I need to repeat this now over and over and over again. Right? So I need to keep track of this stuff, right? So actually, now that I know that there's that many numbers, I don't need to go into a while loop, do I? What could I do? I could go into a for loop, right? For int I equals 0, I is less than num numbers, actually divided by 2, because I'm going to do pairs at a time, right? I plus plus. There we go. And what am I, is that right? No, I'm going to go by pairs, so what do I need to do with my I? Plus equals 2. I'm going to go up by 2. So 0, 1, 1, 2, 2, 3, 4, 5, etc., etc. Right? And I will copy all of this and bring it down here, but I will change it to I and I. And the second time I call it, I'm going to have to call this null. And I'm not going to start at 1. What am I going to start? At 2. Good. Not 1, because then I'd be going 1, 2. I'd be off there. So I'm going to start it at 2. Except that now my I is off in the ranges. What am I going to have to do there? Come on. I don't want to figure out the math, so what I'm going to do is I'm going to go with another index. 0. And no, it started at 1. There we go. And then index and index. There we go. And index plus plus. It's not going to be the most efficient code, right? Or the most compact code here, right? I'd have to go back to my whiteboard here and figure out, well, how can I go up by pairs, but also keep it so that the I is all by itself, right? That's why I'm doing this one in the morning session and the day 1 in this afternoon session, right? All right, so it still compiles. Let's go ahead and make sure that it works. And here I'm going to copy that and modify this so that it is 0 up to num numbers, the traditional idiomatic for loop here, right? And I'm going to go ahead and print out each one. So this is going to be now ranges sub I dot lower and ranges sub I dot upper. And then I'm ending the line, so that should look nice. And let's see, a dot out. Oops. Yeah. Oh, wow. Okay, so it looks like I got the numbers. Not that one, but no, this is the test. Sorry, 11, and then the last one is wrong. So where did I go up to? I got up to that one. 169, that one looks good. Looks like I got halfway, so clearly there's something wrong with my while loops here, right? What? All right, I'm going to change this to a traditional loop then, because I'm only going half, right? numbers divided by 2, but I'm going up by 2, that's why, right? I'm getting out of the number range, so let's go ahead, let's just make this regular, right? Oh, I know, I can still go up by 2s though, right? There we go. And so I'm going to go ahead and get that one, and then get that one. Now I'm off by 2s here though. No, I'm using my own index, that's right. So GCC a dot out. Ah, darn it. Okay. I have to figure. Come on, help me out.
I think you still need I equals 2.
I. Thank you. Is that really going to be off that much? Yeah, because then I can't get any more. str toke will return null, and then a2l will end up segfaulting out maybe. All right, well, there we go. All right, and 11, and then what's the last one? 2, 1, 2, dot, dot, dot. There we go. All right, so that looks good. Why am I going past? It's because this should be divided by 2 as well. And I mean, it should be the exact same loop up here, except that I start at 0. No, this should be good. GCC. All right, yeah, there we go. Okay. Maybe I should put this in a different variable then, so I don't make that mistake again. Int num ranges is equal to, oops, num numbers divided by 2. Now that makes sense because I will only iterate over the number of ranges, the number of pairs basically. Right? That's nice. That's better to use a more sensible variable name like that. Okay. Make sure I didn't break anything. All right. Yep, we're good. All right. All right. Well, is that in order? No. If I wanted to make this, I mean, I don't have to, order this, but if I'm going to do this naively, basically, because this input is not that big, right? Even the full input is not that big. So if I just create a number 1, 1, and then I go through every single range and see if it falls within that range, right? Then I would be only going over 11 ranges or however many ranges are here, right? It's not that big of a deal. But if I had like millions or billions of ranges, right, then I would definitely want to sort them because I want to know, okay, that range is not, I could like do a binary search or something on the ranges, something clever, right? I do want to sort them though, just so that we get extra practice. I want to sort the num ranges, ranges, and then the num ranges, and then what's my next argument to qsort? The size of each one of those elements in the array. So it'd be size of range, capital R. Right? And then finally my comparator that I want to order them by. If I wanted to order them in ascending order, then how do I do that? Let's go ahead and create a integer comparator, CMP range ascending. If it's that's the default, so usually, so you can leave that out. Do I take in 2 ranges, range A and range B? No. What is a comparator? Const void star. Const void star. A, const void star B. Right? All right. My first step is to force them to become ranges. So const range x is equal to const range star of A. And then do the same thing for B and Y here. Now, how do we order these? They're pairs, right? So how do I know that this pair and this pair, that they're like this, or this, right? What I'm going to do is I'm going to look at the lower, right? And I'm going to order them by the lower first. So if lower, or x dot lower, or x arrow, which one? Why did you say arrow? Because it's a pointer, right? It's a visual mnemonic device, right? I don't know if there's a term for that or not, but it's an arrow because it's a pointer, right? If that lower is less than y's lower, then they're in order, so return something negative. Else if x's lower is greater than y's lower, then return something positive. Just keep it simple, 1. Right? I definitely do not want to do the difference trick here because we've already seen that these are huge numbers. Right? So I don't want to be susceptible to overflow here. Else, now the first one, it's not going to happen. I already checked the data. But what if the first 2 numbers are the same? Then we go to the second 2 numbers and order them by those. Right? So I will return if x's upper is less than y's upper. I still don't want to do the difference trick here. Then I will return something negative. Else if, copy, paste, change to greater than, right? Return something positive. Else, now the first component is the same as this, and the second component is the same. They might as well be the same. Return 0. Okay. All right, let's go ahead and use that now. And I'm going to take this and let's print it out again and see if it's actually in order now. GCC, run it. Is it in order? 1122, right? In fact, it's in the order that that they went over. I guess they didn't go in order over here, right? But again, this is not necessary to solve this problem. But also, I don't know what the second part of the problem is. It might be necessary in the second part. So we'll see. We won't have time for the second part, right? But anyway, now what I need to do is I need to iterate over all double numbers. That is 1, 1. You don't start out with 0, 0 because you don't have leading zeros. 1, 1, 2, 2, 3, 3, dot, dot, 9, 9. Then what's the next one after that? 10, 10, 11, 11, right, et cetera, et cetera, et cetera. Right? So until when? Till you are past the highest range. Right? What's the highest range? Because I've sorted it. The last one is it's upper, right? So int max value is going to be range, or not int, I need long, right? Ranges of the last one, which is num ranges minus 1 dot upper. Right? I only need to go up to and including that value on my double numbers, right? So let me go ahead and create a long number, long, what should I call it? That is these things right here. I called it double, what did they call them? Has anybody done this, by the way? No? Oh, they're IDs. All right, so that's why. All double ID numbers, right? So I'll just call it ID. And I'll start it out at 1, 1, right? Okay. While ID is less than or equal to the max value, right, I will, 1, check each range. If in the range it is invalid, count it, right? Then 2, I need to set myself up for the next iteration of this, create the next double ID number, okay? Well, I could write them all out. I don't want to do that, right? Because that's too much work. Any ideas in C? Okay. ID plus equals what? 11? All right, that'll get me to 99, but what happens at 99 when I added 11? 101. Does that get me to 101, 0? No. And it's not just multiplied by 10 either. Right? Basically what I want, if this were Java, what could I do? I could concat and concatenate them, right? I could convert this to a string, convert this to a string. I could say something like this: ID plus an empty string plus ID, and that would get me to string concatenation in Java. All right, don't have that in C, do I? But I do have another thing. S printf. What if I did %d%d, and then I did ID ID? Right? Wouldn't that double it up and turn it into a string? And then once I've got that string, what could I do? ID is equal to A to L of that string. I'll just call it foo for now. Right? So I need to print this to a string called foo. and then I could convert it back to an ID, a long, right? That means I need char foo. I'll just make it big enough. There we go. I could reuse the data string at this point, but oh well. Foo, is there a better name for that? Temp is probably slightly better, right? Because it is temporary. All right, there we go. Let's go ahead and have some, I don't know, printf, some debugging here. Debug, right? Trying percent, is it LD for a long double, or for a long digit? ID, right? There we go. And let's not go to the next line. Let's go ahead and go dot, 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 right? And this should at least work. Oh, there we go. LD and LD. There we go. This should at least run through all of them, right? Yeah, and that was probably the maximum because is that, no, that doesn't seem right. Oh, 1 1 1 1. Okay, that's definitely wrong.
Doesn't ID have to be equal to 1?
Yeah, I need. Okay, so int I is equal to 1, and what I need to do is I need to increment I plus plus, and then that's what it should be. It should be I, not ID. Right. So now I'll go 1, 2, 3, 4, and then double up each one of those. And I still. It's not going to matter there. Gee. Yeah, warning. Tell me all about the warnings. There we go. And it looks like we're doing it. So 21,207, 21,207. And then the last one that we try is this guy right here. And that looks like it's within the range. And then we go past the range. Right? It's not very pretty yet, but that's because I still need to do 1. Right? Check each one of these ranges. For int, I've already used I, so let's go ahead and use j is equal to 0. J is less than num ranges, j plus plus. Right? I need to check to see if it's in the jth range. Right? So if ranges of j dot lower is less than or equal to my ID, and ID is less than or equal to ranges of j dot upper, then it's invalid. Printf invalid. Oops. Invalid. End the line. Right? Otherwise, you get down to the end and whatever. When do I say valid? Let me go ahead and create a Boolean then. So bool valid is equal to true. We'll assume that it's true until we find otherwise. So valid equals false. And so down here I'll say if, in fact, I can move this. If invalid, then printf invalid. All right, I'll fix that later. Else printf valid. End the line. All right. I don't know if we're going to be able to finish this. All right, so, whoa, it didn't compile. What was wrong?
Your estimate is invalid, but your Boolean is just valid.
Invalid. Oh, sorry, valid. Yeah. Okay, there we go. That's why it's not compiling. Come on, there we go. All right, still not compiling. Now I'm going to actually have to read. Oh, duh. If I'm going to do Boolean stuff, what do I need? std bool. Come on. All right, now did that work? Yeah, just warnings now. All right, so lots of invalid, right? I could now suppress that if I want to.
It's like reverse now, because you changed it to valid, but now you're
Oh.
invalid every time it's invalid. So you have to swap the.
Ah, yeah, okay. Invalid. There are only 8 anyway, I think. So I actually need to counter anyway. So if it's invalid counter plus plus. So let's go ahead and create that. Is equal to 0. This should be int. And then the very end, that's what we're actually wanting to report. Printf num invalid %d and the line, invalid counter. Hopefully this is 8. Okay. That's what this says, right? Oh no, I need to add them up. Come on. Fine. All right, so int it's a long invalid total equals 0. And when I declare it to be a counter plus equals ID, all right, and printf total. Now this is a %LD and the line. There we go. Is that the same as this test right here? It is. All right, moment of truth. I don't think we have enough time to fix it if it's wrong. So we're gonna just go with full GCC. It'd be much faster if I didn't print anything. 644 invalid, and there's the total. This is where I would put it in. Cross your fingers, everyone. Hey, we got the right answer. Now you can go on to part 2, which we do not have time for, but we have time to read it. The clerk quickly discovers that there's still invalid IDs in the range. An ID is valid if it's only made of some sequence of digits repeated at least twice. So yeah, that's going to be a lot. At least twice. So what does that mean? Oh, 1, 2, 3 is 3 times. That's 12 times. 12 is 12 times. Oh, wow. Okay. That's going to be, wow. I'm going to have to think about that. And we're definitely not doing that in 3 minutes here. So, have fun with this. There will be no class on Friday because something has come up, but we will come back next week on Monday and Wednesday, maybe Friday. It depends on if you want to. And I will bring, either we'll do this again or we'll bring old exams, right? But otherwise, you have your hacks this week and labs next week.